So I am creating a new file in Collaboratory. So here, so I have a Collaboratory file over here, and I am renaming it as denoising Autoencoder. So for this, I have my data set inside the folder. So I'll be mounting my drive first. So here my Collaboratory file has started running. So I'll mount the drive using the mount drive option and connect to the drive so that my data set can be read. So I have mounted the drive, and then I'll read the data set from there. So in my drive, I have my data set inside my collab notebooks, where I have a folder with FDP name. There I have a satellite data. So I'll be going to this folder. I'll change my drive and go to this particular path, and then I'll see what all things are present over there. So after that, you need to actually unzip the data. That is the satellite data.zip file that is provided to you. Those who have not unzipped it, they will need to unzip this particular folder so that you can read it. So actually, I have already unzipped it, so I do not need to zip it again. So I do not need to unzip it again. Otherwise, if you do not have it, you can run this command and take out the data set here. After this, you need to split the data using pip install. First, you have to install the split folder. After this, import split folders, split folders dot ratio. Inside this, I have a name as satellite data. Then I have to move this to the split data folder. Inside this, the splitting of data set would be done. So I'm taking seed as 1, 2, 3, 4, and ratio in form of 80:10:10. So please run this. I'll wait for 2 minutes so that you can prepare your data set for further pre-processing. Uh, Hello, uh, Saida, ma'am, we are unmuting you. You can ask your doubt over here.
थैंक यू सो मच मैम। मैम मेरा डाउट ये है कि आपने लिंक शेयर किया, ठीक है, वो मुझे दिखा रहा है मेरे ML4CV फोल्डर शेयर्ड विद मी के अंदर, लेकिन गूगल कोलैब से जब मैंने ड्राइव को माउंट कर लिया, फिर वहां से आप कॉपी पाथ करती हैं तो वो मुझे मिलता ही नहीं है।
Ma'am, see how I am copying the path. Once you have mounted your drive, I hope you can see this cross.
Yes, I can see this.
Then you will get this drive. You go there. Inside that, you have my drive option. Inside that, there are various types of folders present over here. So wherever you want to make your collab file, you can go over there. Suppose I have a collab notebook here where I have various my deep learning files present over here. So I'm going inside that folder here in this folder, and here I have created my this file, today's lab file.
इसका मतलब मुझे अपलोड करनी पड़ेगी ये फाइल पहले?
No, you don't have to upload. Like here, you right click it, go to more option, go to Google Collaboratory. If you click it, you will get a new notebook with untitled name. You got it? I hope this. Any other thing that you were asking?
No, thank you so much.
Right click it there. Maybe there would be that you have not installed. If this is your first time you are using Google Collaboratory, then you will have to install it.
No, this is not the first time. I've already used it.
Okay, then it would be present.
Okay, thank you.
Ma'am?
Yes.
Ma'am, I think you are using the actual data. You want to use the zip file from the shared folder. I think so. Do you want to access the data, the zip data from the shared drive?
Yes, ma'am.
So I think so what you have to do, when we have shared one folder with you, this ML4CV. This is the folder which you have. The link of the folder you must have. This is the folder link. We are again pasting. When you have to just add the shortcut of this folder. Add shortcut to my drive. Anywhere in your drive. And then you can find it from here. I think this is the way you can access the data from the shared drive. Is it clear?
Okay, so can I proceed? So after once you have got your data set, we need to first of all import some important libraries. So first we'll be importing the libraries which we'll need further. So here I have I'll be importing import CV2. Then I'll be importing import numpy as np. Import matplotlib.pyplot as plt. Then from tensorflow.keras import layers to build our model. We'll need this. After this, from tensorflow.keras import model. After this, we need to pre-process our data so that we can access it. What we have to do is that we'll be adding some noise over our data, and then we have to train the data using that noised image and the original image, so that it can learn how to make it similar to the original image. So for this, we need to have a pre-processing step where we'll be resizing it, and then it's going to get stored in an array. So we are making a function. This is the same as it was used in the previous lab by Poonima ma'am. So some of you might have used it there, where this particular function resize it, normalizes it, resize it, and it changes the color from BGR to RGB, and then it stores it in a list. So we have two parameters to be passed, that is the path and the size of image in which we have to store it. So we have two lists, X and Y, although Y would not be required, as in we don't need the labeling, but for the sake of convenience, from which categories it is divided into, you can use this. Otherwise, you can comment it out. os.list dir will be passing the base path inside it so that we can join the path after this. For category, in categories, path is equal to os.path dot join the base path, base underscore path, comma, category, class underscore num. This is required to store the index of the folders that we have. So it would be having two namings, categories, index. After this, another loop to do the pre-processing for resizing and normalizing the images in os.listdir. Path, we have used this path from previous line. Then image underscore array cv2 dot imread os dot path dot join. We'll be passing the path, comma, image that we want to join it. So after this, we have img array that is going to store the BGR to RGB, as it was told earlier also that the CV2 needs to be converted from BGR to RGB. It doesn't have RGB image. CVT color image array, comma, CV2 dot color underscore BGR2 RGB. New array cv2 dot, then we'll be resizing it, resizing the array, size, comma, image size. Then we'll have to normalize it. So we have new underscore array Normalize by dividing it by 255. Then append all these readings into the list that we have taken. X dot append new underscore array, y dot append I'll copy this and in chat box. So this was the function for reading the data set and storing it. So after this, we also need to use this function. So we have two parameters here. So we'll be storing we are going to store the output here in X train and Y train. So we'll be requiring X train when we are going to build our model. To train there, we have to pass the X train equals to X train comma Y train equals to data reading, where we have the final path that we wish to give. So I have the path inside. Split data slash train comma 224. Similarly, I'll have to keep the test data also. So for this, I have X test and Y test variables that would be storing this. So I have data reading, underscore reading, and it is inside split folder that you have used, split data slash test. This name can be different at your end, so please check when you run this. So I'll wait for a couple of minutes so that you can run these things. So I will paste the earlier codes also so that you can use it. Someone was asking from here. Let me paste this %cd. Please change this at your side. Okay. Then you have to unzip if you need to unzip it. then the split folder, install split folder. Then here you have the split folder in which ratio you have to split, that you need to specify, and which folder you have to split. Inside that specification you have to give. So then after that you have to import the usual libraries that are to be needed. Then this is the pre-processing step for resizing, and this is the actual reading thing, which reads the data and it stores it inside your xtrain and xtest, where the resized and normalized image will be stored. So please try to do it. I'll wait for a couple of minutes so that we can proceed further. Robbie, Surendra, the image size that we have specified over here, image size comma image size, actually these are 224 cross 224 images. So we have to give the same name. Okay, these are 224, 224. This is passed from here. So it is same. Data reading is not defined. You must not have run it or okay, thank you, Robbie. Can you how? So, Famina Shiba is asking, can you say how you gave copy path for me? It tried downloading, got stuck in the middle. I think you have a problem writing this statement, that is the %cd. I'll once again tell how it gets. Once you have mounted your drive, inside your drive, you go to that particular folder where you have stored your data or you have shared it. So here I have inside my collaboratory file, here I have the data set with me. So in FDP folder inside this, I'll copy this particular, I'll right click it and copy path. So I'll paste it over here after %cd. So this is the procedure. Um, Amit Kumar Pandey, he's facing a problem in unzipping the file. It says read only. I think that you are using the ML4CV folder to access your data. Either you share it like the way that we have told and take it to your personal folder. Otherwise, download it and store over there in your personal folder and then pass it in your unzip command. The path over there, ML4CV is not accessible to read. Okay, that is the reason you are getting this error.
Amit sir, what I'm thinking that you are reading and writing both in the shared folder, but you cannot do that because you have read privileges in ML4CV folder. So I request you, please, you can see the CD path, the change directory path. This path should be your your drive path, not the ML4CV path. And while unzipping, you can give the complete path of ML4CV by copy pasting. And wherever you will write the change directory, you will get the unzipped file over there. In CD, paste the path of your drive, not the ML4CV drive, because you don't have write privileges. Second is, when you are writing unzip command, unzip space the zip file name, there you can write unzip space, copy the path of zip file. I think it is clear now. In CD, give the path of your drive. In unzip, give the path of shared drive zip file. And when you are pasting the zip file path, wherever
Okay, so let us continue. Now we'll see what is the shape of the array. So we have np dot array. Let's check what is the shape of xtrain dot shape. So it is 324 images, 224 by 224 by 3. So we have xtrain is equals to, we'll be storing this np dot array and xtrain. Similarly, we'll be making it as a numpy array. Test the xstate test np dot array x underscore test. After this, we need to add some noise on our original data. So we'll be adding some noise inside it, and that will be passing inside our model so that it can predict the original images. So for this, we need to create a function named as def noise, which would be taking the array there. I have a noise vector with which amount I want to add the noise. So we have 0.4 noise array is equal to array plus noise factor. Some amount of noise is added multiplied by np dot random dot normal So here we have to return the final clipped noise that would be between 0 to 1 value. So np dot clip will clip it between the values of 0 to 1. So here I have the noise array, comma 0.0, 1.0. So now we'll pass our X train and test so that we'll be getting the noisy data. So this noisy data is stored inside noisy underscore train underscore data noise. Inside noise, I am passing my X train. Then I have noisy test data also. So noise underscore X test. So I'll run these two things. Let me paste it on chat also. This one is to change the, sorry, to check the shape this was, and now Xtrain would be having the numpy array. Similarly, Xtest is having the numpy array. Then I have a function that adds the noise inside data. Then I'll be using this function by passing Xtest and Xtrained values. So please try to run these things. Can we go ahead or should I wait? Okay, Femina is saying to wait. Uh, I'll wait for a minute, then we'll proceed. So after this, we'll try to display some images so that we can see how the noise is added on original images. For this, we'll be creating one function to display def display array1 comma array2, where I'll be displaying 10 values, 10 images side by side, which would be having the original images as well as its corresponding noisy images. Size is equal to n, that is the number of images. Then I have images 1, which has array 1 from indices to array 2 indices then we'll plot the figure plt dot figure pig size as 20, 4 for I image 1 image 2 enumerate zip. I'll be passing the images 1 and images 2. X is equal to plt subplotting the images in a row format dot subplot that would be having 2 rows and 10 images, and that would be going from I plus 1. So plt dot show will display the images that we have read. Plt dot inshow images 1 dot reshape 224 224 3, and then I have plt dot gray and set the get axis as false, so that axes are not visible. X axis dot get x axis dot set visible as false. Then I have ax dot get underscore y axis also as false. So I'll be having my another My another plot will be having the images too stored so that we can see that. So for displaying this, we need to pass the function parameters. Here I have a display. Inside that I have x trained, the original images that we need to see. Then I have the noisy images that we have made by adding the noise. So it is actually noisy train data. Fixed size is not defined. Sorry, fixed size is equal to. So we have renamed it these images, and then we are not getting error. I'll copy paste this code here in chat. This is where we are calling the function. So here you can see that we have two rows. Here the first one is your original images, that is from Xtrain, and then the lower row is the noisy image. It cannot be very clearly seen over here, but we can see, like we have, you can visualize it using plt.imshow. Noisy train data, one for one image we can see. So I'll be passing my second image. Then I have plt.imshow. This is the noisy image, and this noisy image is of the data that is the x underscore train of 2. So this is the original. In bigger format, you can see like this, that here how this looks, these particular images with the noise. Here in this plot figure, there is smaller size, so it's not clearly visible. So I'll wait for 1 minute so that you can run this cell. Saida ji, you cannot copy from chat box. I am pasting the code only so that you can see the typo mistakes over there. You will have to type the code by yourself. You can check the object has no, because you have X capital X's. That is the reason. Dot set visible is not, see, you have to write ax dot get small x axis. X and a's, if these two things are capital, then this would not work. Navaljeet, I was answering to Navaljeet. So I'll wait for a couple of minutes so that you can run these cells. After that, we will build our model. So Navaljeet, I have copy pasted. You can check that there is a typo mistake actually. Just a minute. I think maybe there would be a problem in indentation if the spelling is correct. Okay, you got. Yeah. So, Rajiv, Dikshit, this line which you are telling, the for loop here, we are storing our images 1 and 2, that we are reading the 10 number of images inside image 1 and image 2, and then after that we are displaying these images after reshaping them, and I is storing the number of images that we like in form of indexes 0 to 9, so that in that serial order it can be shown in the plot figure. So this is what this for loop is doing. It's reading these images 1 and 2. Can we proceed or should I wait? You can type it on chat. Let's move ahead to build our autoencoder. So we'll build our autoencoder model now. So I have an input as layers dot capital input, and inside that I'm passing the shape is equal to 224 by 224 by 3. Then we'll be having two things, encoder and the decoder part. Encoder, first of all, we'll be having a layer of convolutional 2D layer. For this, I have layers that I have imported in my previous cell, conv 2D, that is having 32 filters with the size of 3 by 3. I'll be passing my input in this layer. So this is the first layer that I have built, the convolutional layer. Then I have to add a max pool layer. This max pool layer was explained in earlier session. So here I have a max pooling. It is going to give the suggestion max pooling 2D. With 2 by 2 size and padding as same. I have to pass my previous layer output as an input over here. Then I have x equals to layer, another convolutional layer I'll be adding now, layers dot con 2D with 32 filters, comma, activation again as ReLU and padding as same. After this, again, I'll be having one more max pool layer, max pooling 2D. with 2 by 2 size and padding as same. So this is our encoder part. Then after this, we'll have to build a decoder thing. Sorry, Max, my mistake. And I have not used layers also. So here, after the decoder part, encoder part, we'll be having a decoder that is that will be using con 2D transpose layer, so that the encoding thing which is done, we can finally upsample all those things to our original size. So for this, we have layers dot con 2D transpose. This was clearly explained in today's session by Ojha ma'am. She has explained how it upsamples the original features coming from the encoder. So we are using con 2D here to get back to the original size. Then we have activation as ReLU. Then I have a padding as same. I'll be passing the output coming from the encoder to this layer, and then again I'll have to make one more conf 2D layers dot conf 2D transpose with 32 filters of 3 by 3 strides as 2 and activation as ReLU. Padding is same. Then finally, I'll be having layers dot con 2D, my final convolutional layer with 3 by 3 filters and activation as sigmoid. So the con 2D transpose output I am passing in this convolutional layer. After this, auto encoder would store the model. Here I am passing the input size and the output that I would be getting that. So this is the model that we have built. After this, we need to compile the model. So I'll copy paste this. I'll wait for a minute so that you can also perform with me. So someone is asking to scroll up a little bit. I think this is what you want to see. So it is just plot.imshow and extrain or noisy train data is passed. I'll copy paste this also. So this is the model that we have built. You can try this, or you can change the layers also, and you can see what happens. So Aditi is asking, how will we decide the layers in decoder? This is actually opposite mirror image of the encoder. So you'll have to see how it can be backtrack, or how it can be seen opposite to the encoder thing. We'll be printing the summary, so there you can see that how these things are getting formed. In autoencoder.summary you can see. Let me print it. Autoencoder dot summary. So here, like you can see that you have first convolutional layer that is having 224 by 224 by 32 number of filters we have given. So here, when I come to here, my max pooling has downsampled it to 112 by 112 size. So here conv 2D has actually upsampled it and has bring it back to the original thing that was already present. So your motive is to get back somehow by adding these convolutional 2D or and the convolutional layers in between. So that is how the model is built. Do we have only con layer in decoder? We have con 2D transpose layer in decoder actually. Here is to get So I hope model is built at your end. Can I proceed? Okay, so after the model building, we'll have to compile it. So we'll be having autoencoder dot compile optimizer is equal to Adam loss as binary cross entropy matrix as accuracy so we have a model compilation done passing x underscore train y is equal to x underscore train and epochs as 5. Then I have a batch size of 16. Then shuffle is equal to true. Then I have a validation data is equal to x test and x test. Both are same. So you can see I have passed x train and x train both in x and y. Right now my aim is so that we can train our model using trained data as both our input and the target. And setting up this validation data in same form by passing the x test and it's going to learn from its x test training. So I have run this. After this we'll be seeing that how it is going to perform on noisy data. This is just to see that is our model built or not. So actually our aim is are running, so the accuracy may be different from my side and your side also. So this is my predict function autoencoder dot predict x test, and I'll be displaying it using the display function that I have built above. So you can wait for a couple of minutes so that your epochs are run till that time. So please try to build the model and then fit this. Okay, so now we'll try to, till that time we can write our further lines of code where we'll be fitting the model on our noisy data. So I'll store it in my output variable where I have autoencoder dot fit, and now I will pass my noisy data, noisy trained underscore data, noisy underscore train data, and it's going to learn from our original x of train. So again, I'll be running for 5 epochs. And batch size as 16. Then I have shuffle value as true. And validation is on noisy test data and our X test. So this predict function is to denoise the original, denoise the image using autoencoder. So here we'll be passing the noisy train data. So where you have to give the noisy data as an input, and our target would be the original images. So for that, I have retrained the model on noisy data, and then we will predict it. So on predictions, again, I'll be writing the predictions as autoencoder dot predict noisy test data and display noisy test data, comma, predictions. So let's wait for a minute so that it can get trained. I'll paste these lines so that you can check the mistake. Getting pile not found. Uh, Famina, ma'am, your actually your this split data slash train. This folder might not be having the actual data. That is why you are getting, or it might be the case you have missed the slash over here while reading. So either put the slash or check once the path of your data set. Till the time epochs are working on, so we'll be writing the code so that we can visualize the graph. So for as output dot history accuracy, then my well underscore ACC is going to store the output of my validation. Output dot history val accuracy loss is equal to output dot history and we have loss and I have well loss as output dot history. Then PLT dot plot. Here I have my accuracy and I'll be giving the label as training accuracy. After this, we'll also be plotting the validation accuracy in this same graph where I have PLT dot plot, then val accuracy that I have got that would be passed here by val accuracy and label would be given as validation accuracy. So I have validation underscore accuracy the title that I have set is accuracy graph. Accuracy graph and plt dot x label epochs. The x label is in terms of epochs and the y label is the accuracy. So I have my y label as accuracy, then the show function. So plt dot show. In this similar way, we'll also be having the loss graph. So plt dot plot, it has the loss, then it has the label set as training loss. plt dot plot val loss comma label is equal to validation loss. Plt dot title is set as loss graph. Then I have a plt dot x label given as the epochs, same as above. Epochs, in terms of epochs we are finding out. So plt dot y label is the loss that we are getting. So after that we have to show the plot function. Plt dot show will display it. So actually incremented with the number of epochs, but this is just to show how it works, how the autoencoder is formed. So the file that I have provided in the lab folder, that was getting trained nicely. So there the accuracy was getting increased, and the loss was getting degraded with time. So that is the actual graph that should be this that can affect the accuracy. Even in your case it can be different. You can even change the batch size and train it on more number of epochs. Right now we are having less time, so I have only trained it on 5 epochs, but you can increase it. And please try to change the batch size, so you will get different types of results. So this is how the plot function is formed. So after this, what we have to do here, I have not actually displayed the form how it was predicting. So let's visualize how the predict function has given. To see how visually the noise is denoised, and it has predicted the images that was having originally the noise that we have implanted on it. So you can see how good these things are. You need to train it more, change the batch size, change the structure of the model, so more accurate things you can get. So we can even try to see how the feature maps look. So for that, as in previous lab, it was told that Teract is needed. So we'll see once how the feature maps are looking. So here we have to install Teract. Then we have an image. We'll be reading the image from CV2 imread. So I am inside this folder. So I'll see one image from the test and see its feature maps, how it predicts. Inside this, I have a split data, test and smoke. For this particular image, I'll try to visualize. So I have a CV2 dot CVT color img comma CV2 dot color bgr2 RGB. Let me paste the code. This particular code was left. Then I'll have to resize the images. So CV2 dot resize. Inside that I am passing img comma 224. Then normalize the image. img divided by 255 and show that what this image is. Im show and pass the image. So for this particular image, we will see the feature map. After this, we have to import get activations. So from charact get import get underscore activations. Inside activation, I am storing get activation function and passing the autoencoder model encoder comma img dot reshape 1 by 244 244 and 3. Then we have the layer name. Here we have to pass the layer name that we want to see. We'll see for the last con 2D transpose. So we have after this to see how the activations are getting built. So we'll have to display the activations. For this, I have already imported charact. So I have to write charact dot display activation, and then I have to say which type we have to see. That is the C map can be given in various form like jet, gray or viridis, or various types of C maps are present. So I'm passing jet over here. So let's wait till you try these things. Let me wait for a couple of minutes so that you can be with me. I hope you have done till this portion. I have pasted. Let me paste the feature maps correct also on chat. If you have any doubt, you can ask till that time. Um, so there is a doubt that how you label the ground truth as binary image. See, actually labeling the ground truth is in segmentation part. That is not done in the uh, encoder. I'll try to show it in tomorrow's lab. So we'll see over there. Okay. So these are the feature maps. Sorry, I have written wrong dimensions. So these are the feature maps that I am getting. So you can see that some of the things are getting highlighted here. So in your case, it can be different. So we can now, if you have any question, do we have some pre-trained autoencoder models? Even your own model you can use on some other application which you have used. You can save that and use it to test on any other data set. That can also be done, or pre-trained weights can also be used. You can try using upsampling layer also. Here, like we have used conv 2D transpose to in our decoder side. Here, even upsampling layer can also be used. That is present inside layers. The layers, its syntax is upsampling, upsampling 2D, and then pass which 2 by 2 upsampling. So you can ask question if you have any doubt, you can ask. If anyone has doubt, they can raise your hand or you can type on chat. Otherwise, we'll end the meeting.
Participant, is there any doubt or anything you want to ask?